Welcome to Lesson 2 of the Coast A-Level Geography course. Today we're talking about erosion and weathering. This is different types of erosion, different types of weathering, key terms and definitions. So to start with, we're looking at hydraulic action. This is waves breaking at the foot of a cliff to force air in cracks to be compressed. This then causes loose rocks to be dislodged and removed. When the wave retreats, the compressed air rushes out of the crack and can further weaken faults in the cliff face. This is worse during stormy conditions. I couldn't draw this one, so I took this from mammothmemory.net. Apologies for what's about to come. These drawings are the best I could really do. I'm not an artist after all. So this is abrasion. This can often be described as the sandpapering effect. This is when loose rocks and sediment get scraped along bare rocks by the force of the waves. It often smooths and polishes the rocks that sit along the coast that act as breakers of the waves. Over time, the polished rocks will wear away and erode the more sediment that gets scraped into them. Next up is attrition. This is when rocks and sediment carried by seawater collide. The more they collide, the smaller they get. This leads to more abrasion. The rocks and sediment carried off of the cliff edge are then thrown against other rocks that are already carried by the sea. Next up is solution. When the water dissolves certain types of rock, such as limestone, not all rock types are dissolved by the sea, however. Seawater has a certain pH level, around 8.1, and as you can see from the drawing, this is why the sea is green here, because this is the colour that the seawater would turn in a pH scale. This makes it alkaline and able to dissolve more rock types. These chemical reactions take place more in chemical weathering. So corrasion is when rocks are hurled at the cliff face from the force of the waves. This causes the cliff face to chip away and get misshaped depending on whether it is a high or low energy coastline. High energy coastlines can throw rocks at the cliff and cause more damage due to the speed and severity of the waves. This is also worse in stormy conditions as they have more force behind each rock throw. So now moving on to weathering, and weathering A-level is often referred to as subaerial processes. It's a lot better to refer to it as subaerial processes, and we'll look at the definition for that at the end. The first up of the subaerial processes, or weathering, is freeze-thaw, and this occurs when water gets into cracks in rocks and it freezes. This then expands by around 10% on average. The repeated freeze-thaw action puts pressure on the rocks until they eventually crack and break the rock. Freeze-thaw usually occurs when the temperature oscillates around freezing point. So it just means when the temperatures drop, there's more chance of the water forming ice. And as coastal climates tend to be milder, this process is only really effective during very cold winters. The next one is biological. This is when plant roots get into small cracks in the rock that are below the soil layer. As these roots grow, the cracks become larger. This causes small pieces of rock to break away. This can also happen with animals such as birds who excavate material to build their nests. This further weakens the cliff face. Chemical weathering involves the decomposition of rocks from rainfall mainly, and this is a result of a weak chemical reaction between the water and the rock, mainly with limestone. Rainwater mixed with carbon dioxide in the atmosphere causes carbonic acid. This then reacts with the calcium carbonate in the limestone to form calcium bicarbonate. The bicarbonate is soluble in water, and the limestone gets weathered when this carbonation occurs. So the more rain there is, the more this reaction takes place. And as you can see, I've done something similar here with the rain by drawing it as the colour it would be in a pH scale, which is acidic, so it's orange. Slightly acidic. So some of the key words. So these subaerial processes are land-based processes which alter the shape of the coastline. These are a combination of the weathering that we've looked at and the mass movement that we'll look at in another video. A lot of the time, people get confused between the different types of damage caused by erosion and weathering. There are 4 to look at here. So we've got joint, fault, fissure, and crack. A joint is a fracture in a pattern, breaking rocks up into regular sized blocks, looking like a brick wall, similar to the biological weathering, that diagram. That had joints all within the rock layer. A fault is a major weakness within the rock layer itself, which can be exploited by marine erosion. This is where there's like big holes in the cliff face. That would be a fault. A fissure is the smallest of the weaknesses in a rock. This is a few centimeters, mainly in a millimeter across, very small. Think about like hairline fissures you get in your bones. And then a crack, the most common one, is just a small opening and weakness in a rock, only a few centimeters wide. And you get many of these, which leads to more erosion. So that was it for this video. There'll be more to come. This one was a bit of a short one, just to go over some of the key erosion and weathering. As, like I said in the previous video, the A-level spec assumes that you know this from GCSE, but not everyone has done GCSE geography. So thank you for watching lesson 2.